Hey, welcome back, you crazy cats. Today we're going to be talking about specific heat and latent heat, and I'm going to help you get through some of the, learning how to read a textbook and take appropriate notes from it. What I've done here already is I've gone through to kind of save time. I've highlighted some important things throughout here as I've read through it, and I'm only going to do a paragraph or two, but I'm going to help you learn how to take some notes. Now, over here on the right, you're going to see me typing. You guys wouldn't necessarily be typing, but it's going to be a little bit faster with me typing than trying to write it by hand. I'm going to be using what I believe is to be called Cornell notes. I don't know how often or how exposed you have been to this, but I think it's a really good way to take notes. So, one of the first things I would advise you guys to do whenever it comes is in a textbook is read these things up here. All right, this is similar to what we do in class or for a lab. When we talk about these are the things that we should know by the time I get done with this. And these are some of the important things, kind of help guide you what is important. Because when we read a textbook and take notes, what typically happens with students is they end up just pretty much copying it word for word. And we don't want to do that. We want to be able to dissect and pull out what the important things are. So let's get started here. Specific heats of solids and liquids. Well, as I read through here, it says different substances have different molecular configurations and bonding patterns. So what I'm going to do here is, well, first of all, let me back up here a little bit. I always do my notes in outline form. So I'm going to start here by putting the title over here on the right. Now from there, I'm going to start to adjust. It says different substances have different molecular configurations and bonding patterns. Alright, and now I'm just going to keep working my way down here. Alright, underneath this as well. It says specific heat capacity. So now we're really getting into specific heat. Specific heat capacity, or simply specific heat, alright, is defined. So I'm going to go underneath here and is defined as heat transfer required to raise or lower the temperature of 1 kilogram of substance by 1 degree Celsius. Units equals a joule per kilogram times Kelvin, or so I could also use joules per kilogram times degrees Celsius. Now I'm not going to put my degree simple. It's notes, and I know this is that it's degrees Celsius, so I'm not going to worry about putting that in there. Now, as I read here, it says because 1 Kelvin equals 1 degree Celsius, specific heat is characteristic of a substance type. The specific heats of some common substances are given in Table 11.1. Specific heats vary slightly with temperature, but they can be considered constant for purpose. Here we're getting into something new here. The amount of heat Q required to change the temperature of a substance of mass m by temperature difference of delta T is then, and they're giving me an equation. So over here in my Cornell notes, I might put Q equals MC. And you guys could obviously just simply write a triangle. That's not real easy for me to put in here. Delta T. Delta capital T, change in temperature. And I'm ready to go on to the next page. Okay, so I'm going into another paragraph here. Here they're giving me a bunch of information. I might put over here in my notes that this specific heat chart page 390. That way it's easy for me to find if I want to go back and find it. Alright, so here we're starting to get into some more good information they have over specific heat. And it says, the larger the specific heat of a substance, the more heat must be transferred to or taken from it per kilogram mass to change its temperature by a given amount. And I'm simply going to say more mass requires more heat to change temperature. Oh, the larger the specific heat, sorry. That's a different concept. I got ahead of myself here. Larger heat requires more heat to change temperature. Says that is, a substance with higher specific heat requires more heat for a given temperature change in mass with one with a lower specific heat. It says metals have a specific heat considerably lower than that of water. Over here off the side I might say metals, low specific heat. And I'm going to start using this symbol C because I know it stands for specific heat. Water, high specific heat. Thus, it only takes a small amount of heat to produce a relatively large temperature increase in a metal object compared to the same mass of water. Compared to most common materials, water has a very large specific heat. And then here, they're telling me what the specific heat for water is. And so I'm going to go ahead and put it in here. 4186 joules per kilogram, and be degrees Celsius or degree Kelvin. I'm going to cheat here a little bit. And then they're also telling us here that it is 1.00 kilocalories per kilogram degrees Celsius as well. And it says in here, if you ever burned your mouth on a baked potato or hot cheese or pizza, these foods have high water content, and due to the water high specific heat, they don't cool off as quickly as others drier foods do. The larger specific heat of water is also responsible for the mild climate of places near large bodies of water. When there is a temperature increase, delta T is positive. This condition corresponds to energy being added to a system of an object. So, positive temperature change equals energy being added. Vice versa equals taken away. So what I'm doing here is I am going through these paragraphs, all right, and putting them into my own words so that it makes sense to me. In our Cornell notes, so this right here is information that is, you know, maybe definition or important information. Over here are things that I think I might need to know later on. These could be my own thoughts. So like I had my equation. Over here I said where the chart was. I could probably put this up here. You guys could easily have put it all on the same page or on the same line because you're writing it. Here's some specific heats. If they talk about it in here specifically, it's probably something I'm going to need to use quite often, possibly in my homework. So what I want you guys to understand is you don't have to write every single thing down. You want to take time to dissect it so that you're learning it as you're reading it. Too often we get too caught up in just trying to fly through a reading assignment, and when we're writing stuff, we're not thinking about what we're writing, we're just writing everything. So we're taking less time with the reading than what we should. We're taking more time with the writing than what we should, and not getting nearly as much out of it as if we were to take time and actually dissect it and go through it and take our time to understand it. Well, hey, I hope this has been beneficial for you guys. I'll catch you on the flip side.